If I'm expressing 1.24 repeater in a fraction form using the concept of a infinite geometric series, then anything to the left of the decimal or anything to the left of where it repeats is going to be its own value. And then I'm going to add that to, here is where the series is actually going to start. I would have 0.24 and then 0.0024, because it's just going to be the same value again afterwards, and then 0.000024, and so on and so forth. Which means that in this case, my infinite sum is going to be an original value of 1 plus my first term is 0.24 over 1 minus 1 over 100, because it's getting reduced by 1 over 100 every single time. This would be the same as 1 plus 0.24 over 0.99, which as a reduced fraction would be the same as 1 plus 8 over 33. I would times by 100 to get rid of the decimals, and then I would divide the top and the bottom by 3. Well, then the sum of the infinite is going to equal 33 over 33, which was my 1, plus 8 over 33. This is the same as 41 over 33. For the last question, we have our infamous dropping ball question. A ball is dropped from the height of 3 meters. After each bounce, it rises 75% of its previous. What is the first term and the common ratio of this series? Well, the first term is I started at 3 meters, or 3.0, and the common ratio is I'm going back up 75%, or 0.75. I could write it as a fraction as well of 3 over 4 if you prefer. What is the general term? Well, the general term is going to equal 3 times 0.75 to the power of n minus 1. Noting that the n minus 1 is number of bounces. That's where it gets tricky here, where it says, what height does the ball reach after the 6th bounce? I'm not actually solving for n6. After the 6th bounce, well, here's 1, 2, 3, 4, 5, 6. And here's where it bounces back up to. That's actually the 7th term. The same problem happens when we're doing date problems or year problems. We need to account for, is it asking for the number of changes, or is it asking for the number of the term? So in this case, I'm actually solving for term 7. So I could say that term 7 is going to equal 3 times 0.75 to the power of 7 minus 1, or 3 times 0.75 to the power of 6, the number of bounces that have occurred. This is going to be approximately 0.5339. And meters. After how many bounces will the ball reach a height of approximately 40 centimeters? Well, 40 centimeters is the same as 0.4 meters. So I'm going to say that the Tn is equal to 0.4 in this case. And I'm going to be solving for what my n value is. So 0.4 is equal to 3 bracket 0.75, and if I said that it was n minus 1 was equal to the number of bounces, let's call the number of bounces b, which means that when I divide both sides by 3, I'm actually going to wind up getting 2 over 15 is equal to 0.75 to the power of b, and my number of bounces is going to equal log of 2 over 15 divided by log of 0.75, which is going to be approximately 7 bounces. If I'm determining the total vertical height the ball has traveled when it comes to rest, well, when I'm looking at the total vertical height, I need to account for both the vertical height of it dropping and the vertical height of when it bounces back up again. Now, when I initially drop it, there is no vertical height of it coming up, which means that that first term is only going to exist for it dropping, not for it rising. For the rising, that actually starts on term 2. So what I'm actually doing is the total vertical distance is going to equal the falling distance plus the rising distance. The falling distance is an infinite sum starting with term 1. It's the height that travels as it's dropping down, starting with the first one going on to infinity. So I have 3.0, or just 3 if you prefer, over 1 minus 0.75. The rising doesn't start till term 2, so I'm going to make term 2 my new term 1 for the rising, 2.25 over 1 minus 0.75. This would be the same as 12 plus 9, and has traveled 21 meters, going down and back up again until it comes to a rest. All right, there's some extra practice in here for you, but otherwise, that is it for Math 20-1 materials. I'm going to be creating some videos for the first parts of Math 30-1 for the people who want to get a head start. But other than that, make sure you're completing all of your assignments and make sure you're ready to go for next year.